Hey friends, welcome back. In the previous video of this series, we assembled the Apple-1 computer, brought it up and got it working, and also verified that the test program that's outlined in the Apple-1 operation manual actually works on it. In this video, we'll be assembling the ACI board, which is the Apple-1 Cassette Interface board that was released by Apple in 1976 as one of the peripherals for the Apple-1 computer. It was sold for $75. In 1977, Apple released the Apple-2 computer, which had a built-in cassette interface, so this board was no longer needed. Currently, the only way to input data and programs into the computer is to use the keyboard. It's possible to use a serial to ASCII converter to input data that way, but I can't imagine it being that quick, and plus you have to use the keyboard socket for that. So that means you can't use the keyboard while using the converter. With the ACI board, we can load programs into the Apple-1 using audio files. We can also save programs and data to audio in the same manner. The board is quite small and pretty straightforward. It does require a couple of ICs, two of which are proms. These are the A3 and A4 proms. If you remember, on the Apple-1 computer, that one required A1 and A2 proms, and these are A3 and A4. My proms I got on eBay from a seller that was selling blank ones, and he also offered free programming for that. I'm going to post a link in the description for the listing on eBay that I used for that. Additionally, a few 1% tolerance resistors are required. The rest of the components are pretty basic. As I mentioned in the previous video, I'll have these boards available for sale at www.calenchuck.com in addition to the Apple-1 main boards. If you decide to build the Apple-1 computer and just can't find any parts, let me know on the calenchuck.com forum and I'll try to point you in the right direction. Additionally, on the GitHub page that I will link to in the description, I'll have a parts list and also the locations of where I sourced my parts from. Okay, let's get started with the assembly. As you can see in the background, I have the Apple-1 computer ready to accept the board once we complete it. We'll be doing the assembly on the blue anti-static mat behind me, so let's go ahead and move over there and get started. The top of the board is the one with the Apple-1 cassette interface wording. We'll start the assembly with the resistors as usual. These four positions here are for the 10K resistors with 1% tolerance. We have to make sure that these are 1% tolerance, otherwise the board will not operate properly. The resistor under that is 47 kilo ohm. Next, we'll install the IC sockets. And IC sockets are oriented with pin 1 facing down towards the gold fingers. So pin 1 here is where the groove is, and we'll just orient it like this. Then we'll install the single decoupling capacitor. The original used a 0.01 microfarad, but for better reliability, we'll go with a 0.1 microfarad. The two MPS 3704 transistors will be oriented with the flat side facing the top of the board, with the base or the middle pin right here going to the upper hole on the PCB. Finally, we'll install the LED. The anode, or the longer lead, on the LED faces right. Okay, so there's one more step left, and that's to install these phono jacks here. And the jacks that I'll be using are these right here. I'll make sure to include the part number that I'm using on the GitHub page where I'll have the parts list. But I got these on eBay, and I think they actually look pretty cool. The jacks need to be oriented with the receptacle facing forward, so we'll insert it through the back of the board. Yeah, these jacks are a little hard to get through the hole, so it might help to use some pliers to screw it in. But once you get it in partially, it seems to go in the rest of the way fairly easily. There you go. And I'll just orient them in such a way that the leads here on the back of the jacks are facing down. I think that looks great. Just looking over the jacks here, I don't know if we should be using the washers here, because it looks like they're touching each other, and like the upper washer here is actually touching that that footprint that we should be soldering the other end of the jack to. So I think I'm gonna remove the washer, or maybe just move it up so it's not touching it. I ended up removing the washers because they were just way too close for comfort. And I think that looks pretty good. Next, we'll use a small piece of wire to attach these tabs on each phono jack to the footprint, the pad, the hole beside it. So the top one will go into that hole right there, and the bottom phono jack will attach to the hole beside it here. All of the solderable components have been installed. Let's use a voltmeter to check for shorts on the positive 5 volt and negative 12 volt lines. We'll check for shorts between the positive 5 volts and ground, negative 12 volts and ground, and also positive 5 volts and negative 12 volts. There will be some resistance between positive 5 volts and ground, but that's normal. Seems okay. No shorts. If no shorts are found, we can move on to installing the ICs. And we can just basically follow the layout here. It's similar to the Apple-1 computer, where it has the the labels up top, so 1 through 5. So number 1 will be the LM311. The next one will be 7474. The next will be the 2 proms, and the seller on eBay actually went ahead and marked these proms for me, so I can see that this is the 3 and this is the 4, so A3 and A4. So the A3 prom will go into the 3rd position, and A4 will go in the 4th position. The next one is 74LS02. And finally, the last one is a 7410. The last step is to clean the board of excess rosin and flux with some isopropyl alcohol and let it dry for a few hours before applying power to it. We need to add one additional jumper to the main motherboard for the ACI to work. We need to add a jumper between R and C to make this expansion port be available at address C, or memory block C. There are 3 holes on the top row, and R is the first one on the left. The A3 and A4 proms on the ACI are flashed with a program that begins at C100. So whenever we call address located at C100, it will call the expansion port here. While we're in the jumper section, you may remember that in the previous video I had jumpered position W to E instead of W to 1. This was done intentionally to enable running Apple Basic, which resides on block E. Okay, now that the ACI board is dry, let's insert it into the Apple-1 computer. Be very careful when inserting and operating this board with the Apple-1, as issues with the board or the wrong orientation of the board can damage the ACI board itself or the main board. Insert the ACI board into the Apple-1 computer with the component side facing out or to the right. Using a mono audio cable, I'll connect one end of it to the from tape phono jack on the ACI, which is the lower one, and the other end to a tape layer. Since I don't have an actual tape layer with me at the moment, I'll connect it to my Mac and play audio from there. I got the Apple Cassette Interface connected to the audio in port, which is the bottom port here, and the other end is connected to my Mac here on the side. And the way we're going to load data into it is by playing audio on the Mac and telling the Apple-1 to start reading that audio and writing it to a specific location in memory. When the ACI was released, Apple also released this documentation for it, the Apple-1 Cassette Interface document. And it has quite a bit of information here that I think is pretty useful. But one thing that we want to note is that, and we already did this, but the expansion port is tied to the R jumper on the jumper section of the Apple-1. And we went ahead and tied it to the C block of the memory. And that is the only location that will actually work, since the program that's located on the ACI prompts only runs on C100. So if we just flip to the next page here, it tells us how to install the ACI board into the Apple-1. And as I mentioned before, it has to be oriented in this way. Basically, the component side is facing out. And then it tells us how to use the ACI. And the way to use it is to type C100 in the Apple monitor program and run the program at location C100. And once you start running it, the program will be expecting a memory address range on where to write data to that's coming from the audio source. It'll be slightly different for writing data out from the computer, but for now we're just going to do the reading data into the computer. So here's an example on how we would actually do it. So we will type in C100R, which means go to address C100 and run the program at that address, and it's just going to kind of sit there waiting for input. And the input it's looking for is the memory address range on where the program will be written to. And once we type in a memory address and press return, it will start reading the audio. We want to make sure that we hit return slightly before we play the audio, just so we don't miss any parts of the audio that's being played. One other thing to mention is that the audio level of the audio source that's coming in may need to be adjusted depending on the audio source. I found that having my Mac playing at about 80% volume works pretty well. The rest of the document has schematics for the ACI and just the typical like warranty and things like that of Apple products, and also some kind of address. I guess that's the Apple computer address back in the day. And it also has the PROM contents, so you can actually see what the PROM contains and what program it's running. So I think there's maybe 3 pages here, 4 pages. So yeah, 4 pages of source code of the PROM. We don't really need the PROM source code, so we can just put this aside for now, and let's try running the ACI software and input some data into the computer. Okay, so the first thing we're going to do is clear the screen as usual, and then reset the computer. Alright, so we got the backslash prompt and the cursor right under it. So next thing we're going to do is type in C100R and press return. So we know that the PROM is working because we got this little asterisk here right after the value at C100, and it did not return back to the wasmon prompt, so it's actually waiting for input from us. The input that it wants is the memory address where to actually start writing data into. And we can, for example, type in 0.f, and it would actually write into those memory addresses once it starts reading data from audio. But where the program is written to is actually important because each program requires a different location. Because of the way the programs are written in assembly code, it's not really portable. It really has to be written into a specific memory location because of the way that jumps and things like that are set up. So basically when you say jump in assembly code, it will actually jump to a specific location once it's converted to machine code, and you can't really change that once it's assembled. So we're going to load a piece of software into the Apple-1 right now, and the location of the software is going to be located at 280, memory address 280, and we'll just basically say write it all the way to FFF, as much data as will fit into it, and press R right after that to say, hey, run this prompt. So now, before we hit return, we want to make sure that we have the audio ready for us to play. And I have the audio ready on my side here, so I'm going to press return, and then I'm going to press the play button on the audio right after that. Okay, so we're reading the data right now, which will take approximately 30 seconds. This program is about 30 seconds long. That's how we can gauge the size of the program. Okay, so it looks like the transfer has completed because we got the prompt back from wasmon. So whenever the ACI program finishes the transfer, it returns control back to wasmon. So we can basically type the wasmon commands as before. So let's try to type in the 280 address that we just wrote data into, dot, and then 28F, just to kind of see what the first few bytes are. Alright, so that's the data that was actually written into the memory locations from the audio file. So the next thing we want to do is run the program that we just transferred, and to do that we just go to address 280, press R right after that, and then press return to run the program. And that person looks familiar. That's actually Steve Wozniak, and this software is actually I think the 25th or the 30th anniversary of the Apple-1 computer. Somebody created this software, and yeah, so this software, this program just displays the face of Steve Wozniak and Steve Jobs, and I think it probably repeats itself, but I haven't tested that yet. And that is the Apple's 30th birthday. So we were able to transfer software into the Apple-1 and then run it directly on the Apple-1. It's much quicker than having to type in every single address and data for each address one at a time. So let's try to load something else into the Apple-1, and this time what I want to load is actually Apple Basic, because once we load Apple Basic into the Apple-1, we can run a wide variety of basic programs on it. So I'm going to go ahead and stop this program and clear the screen as before. Just reset the computer and try to load Apple Basic into the computer. Okay, so we received the prompt back. I actually had to retry this a couple times, and I realized that the volume had to be increased to 100% for this basic program for some reason. The other one didn't need that. So yeah, you really have to play around with the audio file and just try different things, because sometimes the board just doesn't work very well. You have to find that sweet spot. Okay, so we got basic loaded in. At least we know that it's loaded into memory. Let's see if we can actually run it at memory address E000. So we'll type in E000R and then press return. Look at that, guys, we get the basic prompt. So now we can actually type a basic program into here. Let's do a basic hello world program. I had to do a rub out there because I made a mistake. And look at that, it prints hello world. If we actually want to write the program so that it runs on the run command, we have to add line numbers. So I'll type in hello world. Line 10, and then at line 20 I'm just going to say go to 10, and then type in run and press return. Awesome. And there we have it, friends. We got basic running on the Apple-1. I then spent some time playing some basic games on the Apple-1, such as this game here called Codebreaker, and the objective of this game is to break the code using the 6 letters, which are the first letter of each color, and every time you do an attempt, you get a clue back telling you whether you got it right and in the right position, or you got it right but in the wrong position. And you're scored based on how quickly you can do it. And that will be it for this video. We assembled the ACI board and used it to load programs into the computer. Now we can load it with any program we want, including basic programs. Additionally, and I didn't test it in this video, but we can save programs and data on to tape using the same method, but just using the other jack on the ACI. This makes the Apple-1 a much more versatile and practical tool. I hope you've enjoyed watching this video. Please don't forget to click the like button and subscribe if you haven't already. In a future video, we'll be building a case for the Apple-1, so be sure you're subscribed so you don't miss it. Bye-bye.